All right, moving on with determinants. So far we know how to take the determinant of a 2 by 2 matrix. We know how to take the determinant of a 3 by 3 matrix by expanding upon the first row. Then we learned how to take the determinant of a 3 by 3 matrix by expanding upon any row or any column using minors and cofactors. And then there's this last way of taking a determinant of a 3 by 3 matrix. This one's called the diagonal method. This one is my favorite method because I think it's the easiest to memorize and I think it's the easiest to do the computations with as well. So in the diagonal method, the very first thing that we're going to do is we are going to copy the first two columns down next to this here on the right. So 7, 2, 4, and negative 4, 0, 1. And then we draw some diagonals. So I'm going to start at the top left and draw a diagonal down. And when you do this diagonal, you should be doing the multiplication between the numbers that you hit. So 7 times 0 times negative 5 gives me 0. Then we do it again. Negative 4 times 3 times 4, so negative 12 times 4 gives me negative 48. And last, 6 times 2 times 1 gives me 12. So you're going to draw 3 diagonals from the top left down to the bottom right. Then what you do with these numbers is you add them. So 0 minus 48 plus 12 gives me a negative 36. Okay, now we've got to do 3 more diagonals from the bottom left to the top right. So 4 times 0 times 6 is 0. 1 times 3 times 7 is 21. And negative 5 times 2 times negative 4 gives me 40. And same thing here, we add these numbers. So that gives me a positive 61. Then you take the bottom number here minus the top number, and that's going to give you the determinant. So the determinant of A is going to be negative 36 minus 61, and so the determinant of A here is negative 97. Now we've taken the determinant of this matrix lots of times already. We did it by expanding upon the first row, I think right here, and then we also did it by expanding upon the second column. And each time we always got that our determinant was negative 97. So again, it doesn't matter what method you use, you're always going to get the same answer. And this just confirms one last time that we have the correct answer for this 3 by 3 matrix. And do a second example with this diagonal method. I encourage you to pause the video at this time and see if you can work this one on your own. So our first step is to copy down the first two columns, negative 8, 4, negative 1, negative 2, negative 6, negative 3. And then we're going to draw those diagonals and do the multiplication. Negative 8, negative 6 times 0 gives me 0. Negative 2 times 7 times negative 1 gives me positive 14. And 6 times 4 times negative 3 gives me 24 times negative 3. And so that gives me a negative 72. Okay. Remember, we add these numbers together, so negative 72 plus 14 gives me a negative 58. Then I do the same thing with diagonals going the other way. So I have negative 1, negative 6, 6, so that gives me positive 36. 3, or negative 3 times 7 times negative 8. So that's negative 21 times negative 8, which gives me positive 168. And 0 times 4 times 2 gives me 0. So if I add those together, that gives me 204 on the top. So the determinant of B is my bottom, negative 58, minus my top of 204. And negative 58 minus 204 gives me negative 262. So you can see why this is my favorite method. You can see it's a lot faster than by using minors and cofactors, and we don't have to choose any row or any column to expand upon. Now we also did the determinant of this one using that expanding method, and we saw that we got the answer here was negative 262, so that's the same answer that we get down there. Okay, I'm going to stop this video here, and in the next video I'm going to show you how to check the determinants by using your graphing calculator or even just a website that I found.